Hello everyone, welcome back to IGCSE Organic Chemistry series. This is part 4 of the series. So in this video we discussed a lot of things including fuels and fractions. We also discussed about polymers, particularly addition polymerization. So let me know if you have any questions or if you want me to do any specific topic or topical questions. I'm looking forward for all of your feedback. Let's get started. Alright, so now in this section we'll discuss fuels and fractions. First of all, what is fuel? Fuel is basically a substance that releases energy upon combustion or burning. Now there are many different kinds of fuels, but let's look at three examples. First, we have a solid example, which would be coal. A liquid example, and that is petroleum. A gaseous example is natural gas. Remember, the main constituent or main component of natural gas is, you know that? We have studied that before. It is methane. Methane, if it is an alkane, because ANE and meth group, so one carbon, CH4. Now, we'll study more about petroleum. Now, we have studied about fractional distillation, right? Not in this series, but you must have heard of it. So in fractional distillation, basically we have a mixture of liquids, right? So there's a mixture of liquid, and they have different boiling points, and it is heated. When one of the liquid reaches its boiling point, something like this is just a rough diagram to show you how just like to a review of what happens, right? So when the first liquid reaches its boiling point, it evaporates. Here it's condensed, there's a condenser, and then turns back into liquid, and it's collected here. Then again, when all of this liquid has boiled and it condensed, it stops, so it can be separated, and then this is removed, taken away. Then the heat is increased again. So now the second another liquid which has this boiling point evaporates, and then comes here and is separated again. Then this is taken away, and then so this process is continued until all of the liquid has separated into different components. Now these components are also called as fractions. Okay, fractions. Fraction is the distillate, because we apply distillation on it, right? So this is a distillate that separates at a specific boiling point. Now, we studied about petroleum. This is a liquid fuel. Fractional distillation is also applied on petroleum, so let's have a look at that. Alright, so here's what happens when our petroleum or crude oil, but we'll use petroleum here. So the petroleum is heated. When it's heated at 20 degrees, these gases is released. When the temperatures increase to 70 degrees, naphtha is released. That means naphtha becomes to a gas, and then reaches there. And then third, 120 degree, gasoline, paraffin oil, diesel oil, lubricating oil, fuel oil, and residue. All of this is how petroleum is separated into the following fractions. Now, if you notice that as you go from bottom to up, there is a trend that's going on. We need to know that. First of all, above fractions that are on top of the fractionated column have a lower boiling point. You can see 20 degrees, while at below it needs to be heated up to 600 degrees, which is a lot, right? Second, they also have lower viscosity. The viscous means fluidity. If you see residue, it is very less viscous. It doesn't really it's not that fluid. It doesn't flow easily compared to oil, for example, compared to this paraffin oil, which flows, or gasoline, which is a gas which flows which has even lower viscosity. Okay, so as you go from bottom to up, viscosity decreases. Third, more higher volatility. Volatile is something that can evaporate easily. So as you go from bottom to up, volatility increases. And finally, it has a smaller chain length. The fractions that are at the bottom has so much carbon. It has C20, C70, while at the top is may have only one carbon as well. So as you go from bottom to up, chain length also reduces. Bottom to top. Alright, so now we will look at the properties and uses of the following fractions that was obtained from petroleum. Now I want you to focus on uses because you will be asked about uses, and you need to have like a general idea about the boiling point and a number of carbons and all that. So first is refinery gas. It has a very low boiling point is low, number of carbons is also very low. What are its uses? For heating and cooking. It's stored in bottled gas. All right, so the second one is gasoline or petroleum. It has increased boiling point, it has more carbon, it's also flammable. What is the use? Used in fuel in cars, which is very common. We know that gasoline or petrol, we are aware of that. Third is naphtha. Naphtha is volatile and flammable. What is the use? It's used in chemical feedstock, used to make chemicals. It's also used to make medicines. Number 4, kerosene or paraffin. It is colorless, odorless. It's not soluble in water. What is the use? It's used as a fuel in jet engines. So petroleum is used in cars. Kerosene is used in jet engines. It's also used as a heating oil. Number 5, diesel oil. This is viscous and it's a fuel in diesel engines. Fuel oil. Fuel oil is basically a fuel for ships. So we studied jet engines, diesel engines, cars, and ships. Ships is for fuel. Ships uses fuel oil, and it's also used for electrical heating system that we have at home. Number 7 is lubricating oil. It's basically to lubricate, to reduce friction. It's viscous, it has high boiling point, and its uses are to use as waxes or to polish. Finally, we have bitumen. This has the highest boiling point. It has most amount of carbon atoms, just more than 70. It's insoluble in water, high density, and viscous. So this is used to surface roads or roofs. So these are the uses of the fractions obtained by petroleum. Alright, so now we're going to study another concept which is known as polymers. So before explaining polymers, I want you to consider this example. So let's say we have ethene. This is going to be C-double-bond-C, and then H, 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 and H, 4 hydrogen. Let's say if it reacts with another alkene and another alkene and another alkene. Let's say it goes on and on. So what happens here is that the double bond breaks in all of them and they form a big chain. C bonds with C, bonds with C, bonds with C again, and then it goes on and on and on, and this continues. We can add our hydrogen here. This is the previous it attaches to the previous carbon. What is happening here? We can see we had so many ethene molecules. The double bond breaks and they attach to each other and form a chain of something. We call this as polyethene. So you can see the process of conversion of ethene, a simple ethene or a monomer ethene, into a polymer ethene is known as polymerization. There's another way to write this. We can write C double bond C, and then it has H. This is another way to write the equation of polymerization. We have n number of ethene. They undergo polymerization to form a polyethene. Can you see the repeating unit? This is the repeating unit, right? One repeating unit. This is another repeating unit, and so on. So we'll write one of the repeating units, which is this, and then we'll add H. You have to draw these two lines because both of these carbons are attached to a next carbon. We make our bracket and we write N. And we have a chain of polyethene that has N repeating units. So this is called polyethene. Common name of polyethene is also known as polythene. You may have heard of this polythene. Polythene is very popular. It is used in plastic bags. So plastic bags, you have heard about polythene plastic bags, right? That is made up of polyethene. Plastic bag, chairs, toys, building blocks, these everyday items are made up of polythene. Chairs, building blocks. So based on this above information, we can define the following terms. First, monomer. What is a monomer? A monomer is a single unit, in our case it's ethene, single unit that enters into polymerization. Polymer. What is a polymer? A polymer is a complex structure, as you can see above. Complex structure, also known as a macromolecule, that is resulted from polymerization. In this case, is polyethene. So now we know what's a monomer, which is converted into a polymer during the process of polymerization, and this helps us to define what is a polymerization reaction. A reaction where monomers in large numbers link together to form a polymer. Now, you may have remembered addition reaction before, where the double bond was broken and HCl or some other molecule reacted with it. Here, this type of polymerization is especially known as addition polymerization. Why? Because the double bond is broken down. So monomers in large number link together after the breakage of double bond. The key word is that the double bond is being broken down in addition polymerization. We will study another type of polymerization, which is known as condensation polymerization, in which the water molecule is removed. We will go there later. So now we studied one kind of polymer, which is polyethene, and we studied its use, right? Now let's look at some common polymers and their uses. Or polythene. Polythene is the most common plastic which is used in plastic bags, in toys, chairs, building blocks. You can look at this image. This is the common everyday plastic that we use a lot. Now, let's move on to another one, which this is propene. So propene is can be drawn as C double bond C. It has hydrogen on 3 of its carbon, and here it has another CH3 group, but for our case we'll just write it up and we'll write N here. So this polymerizes into polypropene. Break the double bond, extend the lines, and write N. So what happens? Propene is converted into polypropene. If you look at this this rope on the side, this is this is made up of polypropene. It's also used to make fishing nets as well as water bottles that we're using at home. Remember that you have to learn the uses of them. You have to learn the names of them. For example, it's called polypropene. because you will be asked in the question paper. So next is chloroethene. This chloroethene is also known as vinyl chloride. So first we have an ethene, C double bond C, and it has a chloro. That means it only has one chlorine. It is not di or some other type of chlorine. Okay, this undergoes polymerization, and I'll duplicate it, just a moment. Duplicate, and it forms double bond here and N. So what does this form? This is known as polychloroethene. Polychloroethene. Now, another name for this is also polyvinyl chloride or PVC. Polyvinyl. You may I think PVC is very popular word. It's a common name for polyvinyl chloride, and it's used a lot. It is used to make PVC pipes. These pipes that you can see here, these are PVC pipes. These are used at homes, in bathrooms, and they're very useful. They are made up of PVC, polyvinyl chlorides. Another use is to coat the exteriors of washing machines or microwaves. These electronic devices are covered or are coated with PVC. Washing machine, microwaves, etc. Now moving on. Now we have tetrafluoroethene. Okay, so how do we do this? It says that it's ethene, so we have n number of double bonded 2 carbon atoms. Tetrafluoro, so it has 4 fluorine atoms. This undergoes polymerization, and the double bonds break. The fluorine remain where they are, 4 Fs, and we get polytetrafluoroethene. Polytetrafluoroethene. Now, another name for polytetrafluoroethene is also Teflon. Teflon is a very common word. This is how we refer to Teflon in everyday use. It is also called as polytetrafluoroethene can also be called as PTFE, because this is used to coat non-stick pans. You know, the non-stick pans that we use at homes, even though they are found out to be unhealthy for us, they have a lot of disadvantages for our health, but a lot of people prefer to use non-stick pans. They are coated with PTFE or Teflon. Non-stick vessels. Another use is the soul of iron. It's also made up of Teflon. But the most common everyday use is to coat non-stick vessels. Now moving on, we have phenylethene. You must have seen this kind of plastics. This is I'll write the use first here, because since we're here already. Package fragile goods. When you're transporting television or refrigerator, all these goods are packed with this polymer. Other than that, also disposable cups, disposable plates are made up of this polymer. Disposable. But what is the polymer? Let's go look at that. This is called as phenylethene. What is the formula of phenylethene? It's basically C6H5. which is bonded to CH, which is bonded to CH2, double bonded to. So let's write it down. C double bond CH2, and then one hydrogen here and then here. This, you know, this C6H5, this is the phenyl group. C6H5 is a phenyl group. The rest is ethene. So we have n number of phenylethene. They undergo polymerization to form polyphenylethene. Polyphenylethene. What's the common name of polyphenylethene? It's called as polystyrene. It's extremely important to know the other or the common name of these polymers as well, because you can be asked to name them or you can be asked to draw them. So make sure that you familiarize yourself with these names as well. For example, polystyrene, Teflon, PTFT, PVC, polyvinyl chloride, polypropene, polyethylene, etc. All of them basically. So now we can polymerize it. Make sure to draw these two carbons, these two bonds, 3 hydrogen atoms, and here is our phenyl group. Bracket and add your N. Okay, finally, last one is it is called perspex. What is the formula for perspex? It's CH2 double bond C, CH3, COO, CH3. So how can we draw it? Focus on the double bond. C double bond C comes first. Then there are 2 hydrogen, right? So on the first carbon. So draw 2 hydrogen. You have n number of perspex. Okay, on the other carbon, first we have CH3, a methyl group, and then we have COOCH3. This undergoes polymerization. The double bond is going to break first of all. Let's break it down. Breaks, and the other bonds are extended outside. Draw a bracket because we have so many of them. This is called as N. So perspex will become polyperspex. Polyperspex. Okay, let's move on to the uses now. So as you can see, this plastic looks like a glass, but it's not a glass. It's a glass substitute. Okay, used to make glass substitute. You may have seen that some buildings, maybe some glasses, they don't really have they're made up, it looks like that it is made up of a glass, but it's actually made up of perspex or polyperspex. Even the windscreen, it's a glass substitute basically. So these are 6 of common polymers. We looked at its uses and the monomers that it is made up of. So now we have seen so many different kinds of plastics which have numerous uses, from pipes to ropes to packaging. But should we use plastics? Is it useful? Is it not? Let's look at some advantages and disadvantages. All right. So the first advantage is that they are non-reactive. They are not non-reactive. That means they are resistant to corrosion. If you take metals, they can corrode. Iron, it can rust, but plastic, it's very good. It does not corrode. It does not resist. Secondly, it's very cheap to produce. You can produce it in labs. It doesn't take a lot of money or time. Sometimes, lightweight. They are a lightweight. Obviously, if you see this plastic, if you go up here, these plastic, This plastic bag, for example, made of polyethylene, is extremely lightweight, which can be used to make bags and toys for children and share. So this is one advantage of using plastic. Now, good hygienic properties for food packaging. A lot, if you will notice that a lot of food is packaged in plastic because it has good hygienic properties. It does not attract germs. Therefore, it's a good option for food packaging. Secondly, it's easily molded. Different plastics is used to make different types of products. You can make cups, you can make pipes, you can make plates, you can make all sorts of things with plastic. And again, it's water resistant. Obviously, plastic bag, shower caps are made up of plastic for this very reason. And it's a good insulator. If you notice, in kitchens, our pot handles are made up of plastic sometimes, or they're made up of plastic sometimes, or in other cases they're used where you don't want them to get hot, right? And odorless, of course, they have no smell and highly durable. They can last years and years without rusting, without corroding. It's very good. But on the flip side, there are a lot of disadvantages as well. It's first of all, it's created with non-renewable sources. Renewable source such as sun or wind, no, not like that. It's made up of organic compounds, alkanes or alkenes. Sometimes, in cracking, bigger organic compounds are broken down to smaller ones. They can be used to make plastic. So it's the source is a non-renewable source. Second point is when burned, it produces toxic gas or greenhouse gas. So we have studied the reaction of combustion with different hydrocarbons or different compounds, and we know it produces carbon dioxide, right? Carbon dioxide is the greenhouse gas. Sometimes on incomplete combustion, it can also produce carbon monoxide. This is toxic, right? If if we stay in a room that has a lot of toxic gas, which is a lot of carbon monoxide, we can potentially die from that. So it's very toxic. Third, it's expensive to recycle plastic. Why is it expensive? First, it's used in a large amount. It's a hassle. It's so hard to collect and isolate plastic from lots of garbage and then transport it to specific facilities. All of this takes a lot of resources. Therefore, it's expensive to recycle plastic. Finally, plastic causes many fire hazards. Now, for example, if plastic is used to make a medical surgical tool, or if it's kept in a very heated room near the kitchen stove, for example, it can cause fire hazard because it can burn. So in high temperatures, we cannot really use plastic. So these are some advantages and disadvantages of plastics. Now, one more point that we can mention here, that most plastics are non-biodegradable. Not all of them, but most of them, because they have created some biodegradable plastics as well. You know those plastic bags that if you leave them for some time, they just start breaking up into like little shreds. That's biodegradable, but most of them are non-biodegradable. What does degradable means? It means that they don't decompose by bacteria. You need to break them down chemically, or do something to break them down. Otherwise, they just stain the environment and don't decompose bacteria. They just stain the environment and cause visible pollution. And have you heard of Save the Turtles? Because the turtles were getting suffocated because of plastic bags. They would think it's jellyfish and they'll try to eat it in the oceans, but it would actually be plastic bags, and they would die. They would suffocate and die, sadly. So there was this movement called, I'm not really sure about that, Save the Turtles. You can look it up just for fun. Don't write this in your answer paper, okay? You should instead say harms aquatic life. Now let's look at what are some correct methods to dispose plastics. Now, I'm not saying that these are is arranged from best to worst or something like that. they're just like there are different ways in which plastic can be disposed. So before the first point is reduce the usage. Now this one doesn't talk about how to dispose it, it just says prevention is better than cure, right? So don't use other materials, use paper bags, use cloth bags. Or secondly is recycle, don't just like throw away your plastic after one time you use. Reuse your plastic bags, use them in other ways, recycle them, decorate, make a home decor or something like that. Don't waste it. This is actually the best ways. Now another way is a landfill, which is shown here in the diagram. Basically, there's a large part of land, sometimes it's also dug to make a big hole in the ground, and the plastic from the whole city, some maybe, or the entire region is collected and thrown there. Now as you can see, it's a very unpleasant sight, but it is this is how they do it in a lot of places. They just throw it in these landfill sites. One more way is incineration. Incineration is basically burning of waste plastic, as you can see here, but it obviously can be is toxic for our environment. Finally, we have biodegradable plastics. Some plastics are oxy-biodegradable. As I mentioned before, they just biodegrade in presence of oxygen. In Saudi Arabia, for example, all the plastic bags that we get from supermarkets, they are oxy-biodegradable. So if we just leave them in our homes, or if we just leave them over time, to just break down and shred into smaller pieces, and they just that's how they're disposed. And this is good for the environment. It's not gonna harm aquatic life. Like turtles are not going to suffocate in those plastics. So it's much better.